Let's check. Yes, good. Just to make sure if there is any problem or some redundancy. Okay, good. So, okay. So, well, what is basically the mentality, right? So you deal with an object, and right now we'll see what is an object, what is the class, what are these terminology, but you deal with an object as something that is black box, right? And this mentality of encapsulation, well, one of the terminology words in object-oriented programming, or dealing with something as like closed box, like black box, is a fundamental concept on object-oriented programming, right? You basically have some sort of an object, or well, object of a class or an instance of a class that you deal with this from the outside world, right? So you send some kind of data into it, or read some data from it, send a message into it, read some message from into it, invoke some code to execute into it. But it's at the end something that you don't have the implementation for, right? Good. And well, that's one piece of the philosophy that you need to understand without using, well, it's more like layman philosophy. Later on we will see the terminology. But then another thing is, generally, you can write any program. In fact, you are recommended to write any program as multiple objects, or well, instantiating multiple objects of classes, right? So you can consider objects to be the building blocks of any piece of software, right? This is really true for any professional level or industry level software, right? They are not just procedural. What we have used in C is called procedural programming. And later on, I have a couple of slides comparing procedural programming with OOP. But procedural programming is, well, you start from the main, you code everything you have. Well, you can write functions, fine, that's good factoring. But at the end, it's still procedural programming, right? There aren't multiple entities, right? Or well-defined entities in your code. While OOP, on the other hand, is not like this. OOP is, well, before even writing the full program, you build the sub blocks of your program, which are classes, and then instantiate objects out of them. And then you glue them together, right, as bricks, and then you build the whole program. Good. And if you think in real life, well, everything, in fact, in real life is composed of these objects. Right here, I'm giving you, well, some sort of an old PC where you have, well, some kind of cables, serial ports, etc., mouse, chip, screen, a keyboard. All of these are objects that at the end, when put together in the correct way, you define, well, your own laptop or desktop, right? Think of anything. For example, your class, 2SH, right? I can think of it as, well, in fact, it can be composed of multiple objects. One object is like the student object, right? So you can, if you define a student class, well, every one of you is really an object of this class, right? That has, well, similar parameters, but different settings, right? Like, for example, date of birth, courses registered for, grades might be, right? All of these things. But then at the end, you are replicas, to say, of the same class, right? And then, well, in addition to this, might be the course itself, the lectures themselves are also objects of the class called lecture. Every time in a weekly basis, we have 3 lectures, right? And basically, well, we have them in the same time. So if I define a class called lecture, I would define that the times, I would define maybe the topics, and these topics are the settings that change. But at the end, a lecture is again a replica of this lecture class. And then, well, instructors of your second year are also can be objects of a class called instructor, right? They are teaching different material in different courses. They have different interests, etc. But at the end, you can define them using some sort of a template, right? Or a general abstraction, which is a professor or an instructor, right? If you think about anything in life, you can really abstract it that way, right? Good. So we keep saying objects, objects. What are objects? Simply, if you, well, and you might already know this by now. We are towards the end of the semester, but I don't really like much like all this kind of wordy theoretical information, but it's very important to at least understand the philosophy, right? What is an object? Is a self-contained element of a computer program that represents related group of features that are designed to accomplish specific tasks. Well, very, very complex statement. At the end, what it means is that one object has 2 things, right? Some sort of features or settings, right? I give you the example of a student, your date of birth, courses registered for, GPA, etc. These are like the feature, the settings, the data of the object. The second part of an object is the task itself, like what you do. Right? As a student, you attend lectures, you do the labs on your own, you go to midterms, achieve excellent grades, right? So these are the tasks you do. So any object can be identified using two things, some sort of features and the methods or the actions that the object does, right? And then also objects, because objects are replicas of classes. Well, so basically they are they are called instances of this class, right? Good. Throughout the remaining of the course, we will see that we make a lot of this terminology, and well, more than them, in fact. So instance, when we talk about an object, it's an instance of a class. What is the behavior of the object? What is the state of the object? Well, some sort of encapsulation, polymorphism, inheritance, well, methods, variables, superclasses, subclasses. These are terminology of object-oriented programming that we have to learn. Like we have to understand what they really mean, right? You have to talk the language of OOB, right? So I told you an object really has two things, right? Generally, one of them is the data, the settings of this object, which is the state of the object, right? What defines an object, right? Make it different from other objects, right? And then, well, the behavior of this object, which is the actions, right? And simply, well, this is an abstract way of viewing it. But if you look into coding, the state of an object is basically defined by the settings of the variables of that object, as we will see later on. And then the behavior of an object is defined by the methods or methods is another way of saying functions, right? Of that object, the actions you do, right? These are the two things you need to understand about. So later on, we will see the class template. You will define variables and then functions or methods, right? This is modeling the action or the behavior. And this is basically modeling the state or the data or the settings, right? That's the general concept of an object in the class, right? Everything will be around this, right? Questions? Well, Nicholas, like I said, everything is kind of an object. Well, professors are also objects. Lectures are also objects. Don't take it personally. Okay, good. So instant variables and methods. So when we said an object is an instance, if I go back here, an object is an instance. Well, did we say this? Objects called instances. And the reason for this is we said, well, you define a template, a class, and then you create multiple objects of that class, right? You can think of a class. This is object, just an object, object. You can think of a class as an extension, a rich extension of a structure, right? We said what is the mentality behind a structure is you are able to define your own type, right? So we have int, double, float, character. These are the built-in types. But what if I want to come up with my own type? Well, in C, the best you can do is define a structure. But in object-oriented programming languages like C++, you can define a class, right? So a class is a data type on its own. It's a template that can you instantiate multiple variables out of it, right? And an object is nothing other than a variable of the type class, right? That's really the general concept. For example, if you have like a class called instructor, well, you can then instantiate myself, right, as an object of that class by saying, well, later on we will see that instructor, well, if I define something like int x, right, you can also say instructor and then I don't know, like mh, right? So this is the ultimate target we want, is we define a data type, which is the class, and then we are able to instantiate multiple variables out of this class. This variable, this instance, if we use the correct terminology in OOB, is the object itself. So the object is nothing other than a variable of the class type or an instance of the class type. Good? So we said, like the first slide we started with, which is this black box, closed box example, where you really want to deal with the object as a closed entity, you only interface with it, right? The encapsulation concept, as we would see later on. So if you want to categorize this box or draw it in a detailed way, you'd say you have some sort of implementation details, right? And these implementation details are hidden from the users, hidden from well, other programmers that want to use your own class. But then at the end, you provide some sort of a public interface to them, right? How to deal with you. And this separation, it's called separation of concerns. This separation between the interface and the implementation is the core of object-oriented programming, right? I implement a class in a certain way, but I only expose to you how to deal with it. You are not required to know, and in fact, you are not recommended to know how I implement it. You don't have access to this. The only thing you have access to is the interface functions that I gave to you, right? If we take a real life example, well, you use a car, well, if you drive, for example, without knowing exactly how it's being implemented, right? Well, maybe a closer example, right now you are in front of a screen, whether it's a mobile phone, a laptop, a desktop, but you don't know all the architecture details of this machine, right? I really doubt any of you that knows all the details, like how the cache hierarchy works, the off-chip memory, the running frequency, pipelining. All these things are very, very detailed and hidden specification. You have no clue about, but at the end, you are still able to use your laptop, right? The reason is the laptop manufacturers give you a user interface that you are able to deal and use and make the best use of your laptop without caring about how it's being implemented, right? That's the abstraction we are talking about. That's a very important concept, right? I hide the implementation details, but I only provide mechanisms for users to deal with my class. Are there any questions? I mute all of you. Now I'm unmuted. So does this make sense? Are there any questions? Okay, good. So now we introduce it in a very high level way. Let's look into some of the terminology in some a bit of a detail. How come? Are non-OOP languages still used today? Well, C is a clear example of this, right? C is widely used in embedded systems, right? For some reason, right? Like, basically, well, C provides you this low-level control, but if you need some object-oriented programming, people go to C++. But also, the more complex the code becomes, the harder it is to verify, right? So C is still commonly used in embedded systems for that reason, right? Because it provides you a very low level control without much of a complexity, right? Good. But OOP generally is really very common in more like industry level high performance applications, aside from this low level control of the hardware. Good. So for concepts, well, another question from Anna, is this what it meant when we talk about front end and back end programming? Well, that's an excellent question, Anna. Front end and back end usually is mostly used in web development, right? Like this is really when it's mostly used. But in fact, if you want to abstract the concept, then you are correct. Back end is the implementation detail, while front end is the user interface, right? So in abstracting the concept, yes, it can apply to this to some extent, right? In fact, OOP terminology is more, say, accurate in that sense. Front end and back end is more like in a web development environment that people refer to jobs in a certain way, right? Most of the time they are intermingled, not very well defined. There are no clear barriers, right? But generally, you are correct, right? Well, sorry, I guess I'm losing power, so give me a second. I'm come back. Okay, so I guess I'm back. Can you confirm you are hearing me? Okay, good. Thanks, Dirk. Yeah. Okay, good. So yeah, let's continue. So I would just say maybe I will continue while I'm really having the camera off because, well, I'm holding my baby as well. So I hope you don't mind. Good. So, well, the concepts of object-oriented programming, right? So, and those concepts it's very important to really understand their terminology because they will change the way that you program in OOB, right? And what we'll make sure is this is the style we'll continue in for the remaining of the course, and when we talk about labs and remaining lectures, we will introduce, there is a reason why I introduced the concepts at the beginning, because later on, every time we write an example, we will basically refer back to one of these concepts. Any kind of, say, way of writing code should reflect back on one of these concepts of OOB, right? Good. So encapsulation, inheritance, polymorphism, abstraction, right? These are the main 4 principles of OOB. The first one is encapsulation. What is encapsulation, right? This black box example we started with is really what we refer to by encapsulation. The reason for this is, well, it really have multiple benefits. The first one is protecting data by hiding it from direct uncontrolled access, right? Assume you are a company developing some sort of software, right? You don't want to reveal your implementation. It might be even an IP that really your business model is to license it to someone, right? Then, well, you are selling it to customers. If you basically don't encapsulate your source code in classes, well, customers to be able to use your code, they will have it, right? They will have the source code. So encapsulation means I hide all the implementation details. I only provide an interface, and well, through this interface, through this documentation, you'll be able to use the code as a customer without having any information about how I implemented it, right? So data protection is one important reason why encapsulation is one of the principles of OOB, right? And then, well, the second more important reason is it's not only for security reasons, it's in fact for the interest of the customer. You don't want people to get confused and get lost in the details, right? I will get back again to the concept of, well, assume, for example, well, this was an example from functions, but this is because what we know so far in the course. You don't know how printf scanf is being implemented, right? You don't know that how it writes something into the screen. In fact, it has to deal with some IO registers, and then it writes some value into it such that it gets encoded correctly and get printed in your own screen. The same thing for scanf or cn, right? But you never cared about these, right? And well, but we were able to really use them without any confusion, right? So you want to hide the unimportant details from the user and only reveal what is important for them, right? So protection is one thing, but also usability is another thing. And in fact, in software engineering for graduate courses levels, there are certain courses and books for, well, programming usability, right? How to best define your interface in a way that is user-friendly without really revealing too much details. Good. What we learn from this? So this is the general concept. Well, when we code, the very first thing that the rule of thumb there is all data in classes should be hidden, to be like should be private. You shouldn't reveal any of your, remember we said an object or a class is basically data and methods, or in other words, state and behavior, right? You should not reveal at all through, well, in other words, don't make it publicly available, all the data of your class. But then how to access them? Well, I guess, well, there are some points in the chat, but simply you access them through methods like setters and, well, something we call later on setters and getters, right? I have some indirect access to the data, right? And later on, I will show you an example of why this is important. But for now, assume you implemented a class in a certain way, right? Maybe I will give you an example. Assume you are writing some sort of a point class where you define a point in the coordinates, right? Initially, you define them as an XY, right? So all your implementation is based on the XY definition of points, right? Cartesian coordinates. And you reveal, well, the implementation of your, well, not the implementation, you give the user interface to this class to be able to use points in some kind of geometrical use case. Good. Later on, you decide, you know what, maybe this is not the most efficient way. I should really define them in the as radius and angle in that case, right? R and theta. So you change the way you implement your point class from Cartesian into basically, radial coordinates, right? But if you do this, well, you will not be able to do this unless you provided a clean interface. As a user, if I had access to how you implemented it, you will not really be able to upgrade it or use a different version. But if I, as a user, I wasn't really aware of whether you are using X and Y or R and theta, and all the functions should really work correctly without knowing this implementation detail, you will be able to upgrade your software from one implementation to another without asking the user to rewrite all of their code from the beginning, right? So making the user code independent of the details, right? Good. Is there any question about encapsulation? Why it's important, why it's good for usability and security, right? Good. Okay. Then the second concept is called inheritance, right? And well, it's also not really completely independent of the encapsulation. Why? Because if I was able to abstract my class into an interface, a general interface, and an implementation detail, I might be able to write another version of this class with exactly the same interface, but different implementation, right? Well, but if I write it from scratch, I didn't make reuse of most of like my original class. But if I know that, well, they have a lot of similarities, you can use this feature from OOB that is called inheritance, where you say, you know what, my new class is really a child of the old class, right? It's a different version of it, right? It inherits it, right? And by using inheritance, you inherit all the code by default of the previous class, and then you modify it on your own, right? So that's basically the general concept of inheritance, is that new classes can reuse the full functionality and data, so the state and the behavior of previously created classes, and then you can modify them accordingly, which means you can really write a base class. Usually people call it base class or parent class, and later on we will see examples of this, and then have different versions of it, right? One example you can relate to is if you are writing some sort of geometry class, right? Where, well, I can have a general base class that is called geometrical figure, for example, that defines, well, what how many sides I have, how many angles, etc. And then later on, I can inherit this class to define specific shapes like rectangle, circle, I don't know, whatever, square, right? So basically, this is inheritance. So it allows you for code reusability. Good. There is a question from Ahmed. So inheritance is how we upgrade code. Well, it's one way that allows easy upgrade or facilitate the code upgrade. It's not the only way, but it's one way of doing this, right? And it's not only for code upgrade. It's also good for readability and usability, right? And again, because you have a public interface that later on you define you define different implementations for it. We did more engineering. So I'm not sure what you mean, Nicholas, by this. But if you are referring to the Python class, I'm not sure if you cover these concepts in the Python class, right? But it's very important to understand what's really happening behind the scene, right? There are different styles of teaching this. One way of, well, I just show you how it works, right? But without understanding the philosophy, you really don't get the concept behind it, right? So you're not able to extend to other languages, right? Okay. So that's inheritance basically. And then, well, if there are no more questions, then polymorphism is the third principle of OOB, right? There's a question from Sana. How would inheritance be used in industry like a software company? Yeah, we will have examples, Sana, about this, right? But one clear example, I will let you know something from my own experience, right? And although in fact it's not in C++ or whatever, it was written in hardware, but it's exactly the same concept of inheritance. Usually big companies, they have one big product or a family of products, and then they sell it to different use cases by having variations out of it, right? For example, if you are building some sort of an IB means basically a black box in hardware that does certain like function, right? A memory module or an FPGA or anything, right? Then, well, a company like Cisco, for example, would need to use your product in a certain way, like in routers, right? While a company like Uber might need to use your product in a very high performance machine learning way, right? A third company like Microsoft might need to use your product in the cloud, right? But at the end, the functionality of the product, the core functionality is the same, while the use case would require few changes, right? So inheritance will help you a lot there because you will define a base product and then different variations out of it based on the company use case, right? So instead of replicating the effort for every use case, defining it from scratch, implementing it and testing it, etc., you really define a base product, and which is your main product, and then the variations out of it will depend on the market you are targeting. I don't know if this is an example that makes it clear, but inheritance there is really the key behind this design cycle in industry. Good. And then polymorphism. Well, yeah, thanks, Sana. So polymorphism really, well, the literal meaning means many forms, right? And then polymorphism comes, I would say, from the same mindset of inheritance. I want really to express actions and relations in terms of, well, in terms of the base class or the parent class of, like I give you this example of you have a base product that you want really to have different variations out of it. The problem is if we didn't have polymorphism, how can I override the original implementation of a certain behavior or a certain function of the parent class, right? So the parent class define an implementation of a certain function in one way, right? Then later on, one use case want to modify this implementation, but I don't want to touch my parent class, right? I want to keep it the same because it's being used by all other use cases. What can I do? Well, polymorphism allows you to say, you know what, this function you want to modify, correct? Modify only in your use case, in your child class, and this modification that you have done for the child will override the implementation you have in the base class, only for this child. This is called polymorphism. This is really the general concept. In programming, what this really means is that if there is a child class that have the same function name, exactly same function name, same parameters, same everything as the parent class, it can implement it differently, and the child implementation will overtake when we call this child. Later on, we'll have few examples about this. But simply, during runtime, the compiler will be able to know whether you are calling the function from your child or the function from your parent. And based on this, it calls dynamically the right function implementation. And this is a very, very powerful feature in object-oriented programming, because remember from last time we talked about overriding, right? Where we said, overloading, when we said I can have the function implementation using different number of input parameters, and then the compiler will determine during runtime which one to call, right? Here, there is that like a similar concept between child classes and parent classes. You will be able to determine which function you want to call based on which object are you in right now. If you have ever heard this term before, for those that are familiar with OOP, it's also called dynamic binding in that sense, because it's dynamic because during runtime, you bind, you associate the function call you have to the actual implementation based on the object you are in. Well, very complex statement. Later on, we'll see examples about this, right? But just take this in mind, that I can have different implementations for the same function between child and parent classes. That's polymorphism. This is why it's called many forms, because one function can really have many faces, right? Good. And then finally, abstraction. It's basically, well, that's really the layman explanation we started the lecture with, which is saying, well, you should separate the implementation from the actual interface, right? So you should really, well, you hide the details, but you only show the model, and you separate the idea from the way you implement them. And well, by doing abstraction, you focus on what the class is doing, not how it's doing it, because later on this how can it change, implementation can it change, while interface, which is the contract between you and the customer, should never change, right? Good. So that's basically what we mean by abstraction. Questions? So Ahmed, what is the difference between polymorphism and inheritance? Yeah, so later on we will see in a detail, but inheritance is simply being able to reuse the code of the parent in another class, while polymorphism refers to if I modify some of this code, which one gets executed, right? So they belay together, right? One of them is trying to inherit the full implementation by default of the parent, while the second one, which is polymorphism, tells you if you modify it, what happens, right? Good. Are there any other questions for these four concepts? If they are not very, very clear, later on we'll see examples how they really work in reality. But you need to put these concepts in mind when we see the examples, we can reflect into them, right? Good. Okay, so what is the benefit of all of this? Again, modularity is one important benefit. I can really separate my code into the meaningful objects in reality. And then information hiding is another one. Usability is another one, right? There are multiples of this. And to be able to really achieve this modularity and separation of concerns and abstraction, you should be able to interact with the object only by calling functions, by sending messages, right? So if I go back, this is not a very practical example, but if I go back to this one, assume, for example, I have a self-driving car, okay? And this self-driving car does some sort of sensor fusion, camera reading, right? So to detect whether there are pedestrians crossing the road or not. And once you detect that there is a pedestrian crossing the road, you need to send an action for your processor, basically to stop, back up, right? Do something to prevent an accident. So if you didn't have this modular design, the class that is doing the camera reading, for example, is different from the class that is doing the actual brake control, right? So they should have clean interface between them. This clear interface usually happens through messages, calling actions, right? So that, well, if I'm thinking in a real use case, what would happen is the camera module, the camera class, will keep reading from the camera video stream, do the analysis. Once a pedestrian is detected, you will send certain action to the other class, which is controlling the brake, stop, right, or reverse, or brake, right? And then this other class will be able to read this message and take the action accordingly, right? This is what we mean by messages between modules. So different objects should deal by this clean interface of messages, right? Good. And then, well, objects, but how to create objects? You really create objects as variables of the data type class, right? So classes are in fact the template of this object. If you don't have classes, you don't have objects. If you don't have int, you cannot define int x, right? And a class embody all the features of a set of objects, like the ones that you should define from them. And then, well, a class defines the data type on its own, and you can consider it as a blueprint, as a prototype, as a template that you can take multiple instances out of it, right? So it's a template used to create multiple objects with similar features. I give you the example at the beginning of, well, class of a student, class of courses, class of instructors, even class of universities, right? You can think of anything around you as really a class, right? How does a class, and this is what we're going to end up with, and then like in Wednesday lecture, we will really see some hands-on to apply these concepts. But how to put all of this in a C code, that's really the structure of a class in C. It's a general structure. And if you open your lab code, you will find really the matrix class is defined exactly that way, right? So first of all, you would have to use the reserved word class, right? This one. And then this really means now I'm going to define a class. I'm going to define a data structure. This is a reserved word. And then you give a class name. Class name is any valid name similar to a variable name. So it should be a valid name. You cannot start with a number, you cannot start with underscore, etc. And then you have two things here. Well, they can be three, but later on we will see the access types, generally two. Private and public. We said all your data should be private. You never should have any data as public in your class, right? Even if you require external access to them, you should access them through other ways that we will learn later on. But simply you declare your data as private. And then later on, most of your methods, unless they are really what they call usability functions or methods or helper methods, that's something that you want to use within the class. Other than this, if you want any function to be used by external wallet, it should be public, right? So the second piece here is basically the public part of your class, which defines all the methods and functions, including a special type of function or method that's called constructor, Don't care about it now. Later on, we will see what we mean by that, right? But simply, this is what defines the behavior of the class. And then, well, at the end, you might really want to define, well, you separate your functions into two types. The interface functions, setters and getters, as we'll learn about them later on, how to access the data in the class, and then the action functions themselves, the ones that do the actual functionality, right? So if you look into it, compare it with a structure in C, well, what is the difference? What do you think? If I'm telling you that this is a class example in C++, how this differs from a structure in C? What do you think? Can you support in few examples? Yeah, go ahead.
Oh, sorry. I don't think C has you can have functions within the structures. I don't think.
Exactly, Hakam. That's one important difference that we said before, is that structures allows you only to encapsulate data, but you cannot define functions or methods inside a structure. Yeah, that's a very important difference. Yeah. What else? Yeah, thanks, Hakam. What else?
There's other regular object-oriented programming differences, such as what you were just talking about, the declaration of private versus public variables.
Exactly. Thank you, Jack. Yeah.
The
scope. Yeah, definitely. So in a structure, well, everything really has the same scope of the structure. It's defined as one entity of data that you cannot have one of them to be private, the other one is public, the third one is protected. So you cannot really differentiate this. While in a class, it generalize it by saying, well, this concept of encapsulation in OOB, you should define few things to be public, which is like user visible, while other things that are hidden, private or protected, right? Which is not possible in a structure. That's definitely another important difference. Later on, we will learn that there are other differences, like for example, in classes, when you create objects or variables of a class, there are things you can execute once you create the object, which are usually called constructors, right? So there are functions in the class that gets called by default, right? Once you create the object, while in the structure case, well, we don't have functions in the first place, but also when you create an object of a structure, you don't do anything. There is no action that is taken into account, right? And so which means I can really initialize the data of the structure when I call the structure. That's one thing, right? But constructors in classes do more than this, right? So we will see later on how to handle memory from a class perspective, right? So it's already 23, so I will stop here and talk to you on Wednesday, unless there are questions. So thanks everyone. I will stay for a few minutes to take questions, but other than this, talk to you all on Wednesday. So Ahmed, there is a question. So what is the difference between, this is the one that I just answered, okay. Okay, so if there are no more questions, so thanks everyone, and well, talk to you on Wednesday then. You already have all this set of slides for this week, so you can also look into them on Avenue. Will you release lab for today? I will do it right now. Yeah, thanks.